Today's demonstration is for MACTrak WebView 2.5, a free upgrade that is now available for existing WebView servers. All the capabilities you will see here, plus many others, are available to all nodes monitored by RPM 3000 cards. A trade-in program is available to provide a very cost-effective way to replace some or all of your old RPM 1000 and 2000 cards with RPM 3000s. Please contact your JDSU rep for more details if interested. We'll start by looking at the WebView 2.5 interface. Many elements of this WebView interface will look familiar to current RPM 3000 users. The biggest adds are Codeword error detection as well as MAC address identification. MACTrak with Codeword error detection uses in-band cable modem or DSAM packets to tell you in real time which impairments are affecting your subscriber services. Codeword error detection is critical because it allows you to know and not guess which impairments are affecting your customers' packets at the data level in real time. This allows you to see if you have correctable or uncorrectable codeword errors on your customers' packets, and if so, why. So to demonstrate this, we will take a look at a couple nodes that have very similar looking spectrum displays. If you came in the morning and pulled up these two spectrum analyzers, which node would you work on? They look about equal. Both have a lot of low-end ingress. Maybe this one hits a little bit higher on the carrier, so maybe this one's worse. So if we take a look at the real-time status and are we generating codeword errors on this node, the answer is no. If we take a look at this analyzer, we see, aha, we are creating codeword errors. We have problems on this node that are very likely impacting your customer service level. Problems that your customer very likely will notice. So it's easy to see how you could work on the wrong node if you do not know whether or not you're having codeword errors on a node at any given moment. The constellation display, the strip chart are largely unchanged with the addition of equalized MER, the pink line here on this strip chart, to the unequalized MER that was delivered previously. A live spectrum display has been added as well. This shows you what the spectrum looked like each time a packet was captured. If you pause a session and want to step back in time and look at a previously demodulated packet, you can. You can step through packets and see what the spectrum looked like at the time each packet was captured. We've also added the impairment dashboard here over on the left side to show you at a glance in a very simple red light, green light format which impairments are affecting your node at the moment and since this QualmTrak analyzer session was opened. Each one of these buttons on the impairment dashboard will turn red if a user-defined threshold for each of the parameters is violated. The top three boxes are here primarily to tell you if you have a problem on a node. Do I have a problem with codeword error, equalized MER, or unequalized MER? If you do, then the bottom 6 buttons tell you what type of impairment is likely the cause of this health metric issue that you have on your node. So in this specific example, the buttons up here in the node health section are red, saying yes, I definitely do have a codeword error problem as well as some MER problems. Based on looking at the bottom 6 buttons, it appears that impulse noise is the cause of our codeword error problem. Now, if we want to be 100% certain of that, we can switch from the strip chart view to the data table view. In this view, each row is one packet that has been demodulated, and this table is completely sortable. So if we sort this on codeword errors and say I want to see the packets that had the most codeword errors, then you can see all these packets that are red because they violated our threshold because they contain codeword errors also violated our impulse noise threshold. So this tells us with certainty that the packets that had codeword errors on this node had codeword errors because of impulse noise. So for linear impairment issues, you can drill down similarly on any one of these linear impairments, be it microreflections, in-band response, and group delay, to see if your packets with the worst performance on any one of these are coming from the same modem or similar modems. So here we see nothing failing for group delay, but if we did have failures for group delay, we could look at the MAC address for packets that were failing and see is it the same modem failing consistently or is it a series of modems. In either case, you can copy this MAC address to the clipboard and you can paste this into your back office billing system to get from this CPE MAC address to the street address to know if you do see multiple modems affected, are they geographically close to one another or are they spread out across the city. If it's only one customer affected, you know exactly where to roll a truck to begin trying to find that linear impairment issue. Now you can use your DSAM as a portable field probe to do the final segmentation. Remember, a DSAM has a cable modem in it. It has its own MAC address. So you could open up your QuamTrak analyzer. You could then filter your QuamTrak analyzer on just your DSAM's MAC address and say, I only want to see packets from my DSAM's MAC. Then you would see only his packets. And then as you step through the plant from test point to test point, starting with the street address of where you saw the linear impairments, you could finalize down to exactly where in the plant that linear impairment goes away. That tells you where the problem is. You can find and fix the problem there and look via your constellation, see in real time whether the impairment goes away when you tighten up a loose cable on a splitter, when you replace a faceplate on a tap, any type of repair like that. Again, since you can also filter on just your DSAM's packets, you can see the complete DOCSIS health of your DSAM's packets from any point in the field back to the head end. And not only do we have the impairment dashboard to make the view very simple here, but we also have advanced impairment charts for those who are familiar with looking at QAM analyzers. You have your EQ tap chart, your in-band response, your group delay. We have an ingress under the carrier to display that can detect whether you have an ingressor present underneath your carrier on some or all packets. Again, you can see all of these wiggle in real time as you go through and make changes in your plant. So, how is this tool useful to help you solve problems? One very common example of how this solves problem is the persistent customer problem, or the repeat truck roll customer. You have this customer who you've replaced their cable modem once, you've replaced their drop cable a couple times, yet they keep calling in. In that case, you would filter on just that customer's MAC address, so you only see packets from his MAC address, and then you would let this thing run. So there's where you'd set your filter to see just his MAC address, and you could also say, I only want to see packets from his MAC address that have code word errors. So now you would start this analyzer up and let it run. If you're not seeing code word errors right now, chances are his service is not being affected. You may get clues from some of the other impairment charts, but if you don't see anything, let the analyzer run. Let it run 24 hours if you have to. Then, when you do see packets that were captured from that customer's specific MAC address that contain code word errors, then you could step through those packets and see at what time those code word errors were present to know what time to troubleshoot that problem. Say we'd run this session on just that customer's modem. You could see, aha, I see at this time of day packets from his MAC get bad, and then you can step through each one of the packets that was captured and see what the impairment was to know what type of trouble it is that you're chasing. So, in closing, WebView 2.5 and the RPM 3000 card can help your techs identify the nature of impairments affecting their nodes, and in some cases localize them down to a small section of plant. Your DSAM can be used as a portable field probe to measure your carrier health from any point in the field back to the head end. This testing can be done in band and doesn't require any open spectrum. Only with MACTrak and the RPM 3000 can you examine both live customer modem packets and the full upstream spectrum to identify all upstream impairments. For more information, please contact your JDSU rep or see jdsu.com/MACTrak for more information.